In this video, we discuss about compile time initialization process. In the last video, we discussed about variable initialization and the compile time initialization process. If the initialization of variable is done during the compile time, it is called as compile time initialization process, which is done using assignment operator. In this video, we discuss about runtime initialization. So runtime initialization, it is a process of assigning a value to a variable during the runtime process, that is after compilation process. To do this, we use scanf function. Scanf function is used to read input from the user through keyboard. So the syntax of scanf function is, there are two sections here like printf function, format specifiers section, followed by arguments section. The only difference between scanf and printf function is, in printf function we don't use ampersand in the arguments place, but in scanf function we use ampersand symbol in the arguments place. Ampersand is used to specify address of the argument. So we see examples. Now I have taken three different variables A, B, C. Now I want to assign values to these variables dynamically. So explicit initialization is also called as dynamic initialization. Why? Because we assign values to variables dynamically at a runtime. So first of all, I want to take a value. So enter a value. As a is of type integer type, then in scanf function we must use format specifier %d, and then I am saying that enter b value. Then in scanf function I am using %f format specifier. Why? Because b is floating point type, and in the third case, as c is character value, I am using %c format specifier. So if I run this particular program, so it is asking for enter a value. Let us say I am giving 10 and pressing enter. Then b value 9.8 and again I am pressing enter. But here we got an incorrect value. So why? Because I am using devc++ compiler. In this, after pressing 9.8 and then enter, that pressed enter is given to c value. So in order to rectify this particular value, so before reading a character value, we use one built-in function fflush. We use one built-in function fflush std in function. So this function clears the previous buffer values. So we get correct values here. Enter a value 10, enter b value 9.8, enter c value plus. Now we got a value 10, b value 9.8 and c value plus. So in this fashion we assign different values at runtime to different variables. Now again, if we run this particular program, again it is asking for some other variables. Now I assign different values here. Now if you look at this particular program, I assign different values. Let us say 100, 77.99. Now I am giving capital A. Now we get A, B, C different values. Instead of giving values directly in the program, we are assigning values using keyboard. So this type of dynamic initialization is called as runtime initialization or explicit initialization. So in this fashion, we can give values. Similarly, we can combine all these three statements in three different places, like printf enter a comma b and c values. So in a single scanf function, I write scanf %d, %f and %c, comma, first %d is meant for a, so I am writing ampersand a, and %f is meant for b, I am writing ampersand b, comma, %c is meant for reading c value, so I am writing ampersand c. So remember one point here, like in the printf function, in the scanf function also, the number of format specifiers must match with the number of arguments and also their type. I am running this program, I am giving values 10 space 9.8 space, I am giving capital A. So we got output A value 10, B value 9.8 and C value A. So in this fashion, we assign values dynamically at runtime to variables. So this type of assigning values to variables dynamically at runtime is called as runtime initialization, and this type of runtime initialization is done using scanf function.